All right, I think we're live.
Yeah, great. So, welcome to today's webinar, the next one. My name is Patrick, and we thought about hi. We thought about a quite funny topic with a bet, but in reality, it's a topic that concerns many companies, and it's very costly and expensive. Because data integration across systems have boundaries, and it can consume extreme millions, and that's why we're here for, that we cut those costs. And yeah, that's what we want to talk about.
Yeah, so for the a bit of social media link bait. It's actually what works and what attracted you guys here as well. But it's actually a true story. So it's all about data integration overnight. So we didn't overstretch it essentially. Just that is a bit of a good catcher essentially. Okay, let me just skip the slides. Let's dive in.
As always, a quick disclaimer from the legal side. Everything that we say is just forward-looking statements, and it contains risk or uncertainties that you know. And yeah,
Let's skip it. Let's go. All the features in anyway. So
yeah.
Cool.
And for those who are new to Flow.BI, it's also possible. It's a generative AI that simplifies and automates data modeling and management. So in short, we help businesses define the raw data vault, including essential components like the hubs and the business keys, the links and the satellites, and while we're integrating with existing data warehouse solutions. So yeah.
Mm-hmm. All right, I think that's my turn here. So let's talk about data integration overnight, how to make this happen essentially. And if we look at the more traditional way, how we organize the data platform team, the idea is that typically we focus our teams on sprints. So the sprints or the team has a specific goal for the sprint that they want to accomplish essentially, or they want to get done essentially with. And sprint by sprint, we typically build out the data model, but also the business model, the information model. So the whole data and information models are built sprint by sprint. We avoid having a big bang essentially. That's what we do all manually anyway, right? So we go sprint by sprint, build out a model, and we generally follow what we call a traceable approach, where we decide what are the business value we want to produce this sprint, and then we identify the source tables we need for that, where's the data coming from, and then shoot it through the layers essentially. And in the raw data vault, we get some additional raw data vault entities. In the business vault, we attach some business logic and information marks. We get some dimensions and facts for the report to be built essentially, if that's your business vault you will produce. So that's the general approach, how we typically work. And again, we want to avoid the big bang approach. And the idea is that data vault has been specifically designed for supporting those agile projects or such agile projects. In data vault, what we see is different, what we call pillars of data vault, 2.0 or 2.1, and that's essentially the agile data vault methodology. It's essentially the approach, how we organize our teams, how we organize the project essentially. Then the data vault reference architecture, which layers exist. When I talk about the staging area or the raw data vault, the business vault, the information marks, that's all essentially coming from the reference architecture. And then the implementation patterns, how do we once we defined hubs and satellites, how do we load them? How do we derive, or how do we implement business logic? How do we derive dimensions and facts from the data model? And the model itself. So an extensible data model, which we can extend over time with additional raw data in the raw data vault, but also business logic in the business vault essentially, and also information models. So it's really designed for an agile build-up essentially, where you go step by step, iteration by iteration, and extend the existing model that you have. That's the basic idea. And what we see is that most aspects in data vault are really pattern-based and based on repeatable patterns, actually. Give you an example, all the hubs and satellites, they all look very similar. I mean, at least all the hubs look very similar, all the links for themselves and so on. They all look very similar, but also the loading pattern is more or less the same. The query pattern, how you derive dimensions and facts, is more or less the same. Well, there's some nuances, right, for type 1 or type 2 dimensions, but that's all about it. And because these are repeatable patterns, we can essentially automate that. And we have code generators, essentially, data automation tools that we can use to generate the data platform, generate all the hubs and satellites, give you the create table statements, but also the insert statements for your entities. That's the basic idea. Let's talk today. It's really about the data methodology. And that's where we have, in this agile approach, we have different aspects from different approaches. For example, I would say that the data vault methodology is 80% Scrum. So we use a lot from Scrum, like the organizations, the team size, and so on. But there's also aspects from Six Sigma, where, for example, when you have a deviation from the standards, that's considered a quality issue, because quality is a deviation from your expected. A quality issue is a deviation from the expected quality that you define, essentially. And so that's what we have. CMI for continuous process improvement of the development processes. PMP, that's essentially the sprint waterfall or the sprint plan that defines the activities in each sprint, and other aspects that are included there, essentially. And the basic idea of it, for me, a very important aspect is that we want to improve the process over time, as in CMI, because when you start a data project, you really have to start with a very initial team. They have some skills, no doubt, but you want to get them to be highly productive and doing less errors and so on. So you have to really develop this team over time, essentially sprint for sprint. It can become sometimes a challenge, but it requires really constant management of the team, essentially, and the issues. All right, and then what we typically do is, and what we always do actually, is that we focus a team on business value. So they should produce something of business or of value for the business. Some report, some dashboard, maybe something else, maybe it's something in related to business process automation or something. But in 80% of the cases, it's really reports and dashboards. So they should produce something where the business says, that's what I wanted, essentially. That's where I put the budget on the table for. And it's less those technical or non-functional requirements, like having a data lake or maybe a real-time database or whatever, right? So that's all nice and funny. And I mean, we're dealing here with tech guys. They love building the data lake, or they love building a real-time database. It's all good, but it's not what the business wanted. They just wanted a report and a dashboard. And in all honesty, in many cases, they really don't care what kind of technologies did you use, as long as the numbers are correct on the report. It's much more important, right? And sure, the usability of the front end and so on. But most of our work in the back end is not that important for them in reality. They might be polite to you and don't tell it that way, but that's what it is. And what we see is that a lot of teams focus on the technical aspects where the business doesn't care for. That's an issue. Or they also, what we also see in some cases is, well, at least initially, like years ago, we saw it a lot actually. We saw a lot that teams were building out the data platform layer by layer. First, they built the whole data lake for all the data sources, added all the data sources there, and then they decided essentially to use Data Vault. They came up with a raw data vault for all the data sets. Everything from the data lake they put into a raw data vault, and then they decide to essentially implement the business logic for some targets. Realized maybe in the business vault already that the way they modeled the raw data vault wasn't fit for purpose, wasn't good, wasn't optimized. Or they realized in the raw data vault they couldn't really extract the data from the data lake, for example. So they're realizing they got some issues, but you build out the whole raw data layer already. And then you spend a lot of time coming up with that, and that's an issue, essentially. So what we suggest is then that you, instead of going layer by layer, like a full layer by layer, right? You go, again, follow this traceable approach where we shoot certain functionalities through all the layers at once. First, get some data, again, from some source system, a couple of tables, stage them in a data lake maybe, then derive the raw data from it, attach the business logic in the business vault, derive the information about entities from it, and build a report you done. And then do this next for the next reports. So report by report and not layer by layer. That's the idea. And that's what we do, essentially. And you should not lose track. And with that, we don't lose track of the non-functional requirements, because you're focusing the teams instead of on technical layers, data vault or the data lake and so on. You focus the teams on the business value, on the reports and dashboards that require data. That's the basic idea, essentially. And that's how we organize the teams here. The typical team organization, that's essentially just as in Scrum. The Scrum size is typically 5 to 9 team members. 9 I find a bit large, but that's what we see in documentation, but also in projects a lot. And we have typical roles like source system specialists, business users, data modelers, data engineers, testers, Scrum Master, or project managers, the dashboard designer, those people on board, essentially. Automation experts, data engineers, and so on. So typical roles. And then if you want to scale those teams, you scale them up by having multiple teams working in parallel. So we don't build a team of 20 people and then have more roles on the team or something. No, we build 2 or 3. With 20 people, I would maybe at least have 3 teams working in parallel, essentially on different or similar aspects of the data platform, essentially. But always focus them on business value, right? Not on the technical aspect. So how long does it take then with this setup? And sorry for going the long story here, the long answer here. How long does it take to build a data platform, essentially? And what we see is that most projects, most organizations, when they decide to build a data platform, they need multiple years to build this. Especially when you count in FTEs, full-time equivalents, it's multiple years of work. That's what you see. And even for small firms, that's what it is. So you have to set up the whole environment, the technical environment. You have to build all the reports, and then what we also see is that when business users get the first reports, they get more hungry for more reports, right? So there's more and more demand for additional reports, essentially. So that's what it is. That's what it is, essentially. And why is that the case? Why does it take so long? Well, because first of all, we need to analyze the source system structures, and they change over time. They change all the time, right? Because the source systems, the applications will be modified, and we have to absorb these changes as well. That's one issue. Then we have to interpret the raw data coming from the source systems, and those interpretations, those business rules, might also change. Well, first of all, we have to define them, and then they change over time as well, and actually much faster than the data structures coming from the source. And that's also part of the project. We have to adjust those business rules, essentially. There's new regulations coming up from the regulator or from the government, for example, from the lawmaker or industry bodies that we have to implement with new reports, new solutions, and more requirements by business users. Again, as they see that you can deliver, they want more reports, essentially, because they need reports for making data-driven decisions. So it's not a case that in reality, when are you done? You're never done, in all honesty, because the data platform, you might be done with the initial set of reports, but then the maintenance or building new reports kicks in, and the maintenance of the platform and so on, upgrading the systems and so on. So it's typically an ongoing effort for most even smaller firms to maintain the system, essentially. It's not a typical software application. When you're done, and let's end the lifetime support. It's because we're done. No new ideas or something, right? No, there's always new ideas. So what could go wrong? I mean, there's a lot of technical risks. What can go wrong, essentially? First of all, you could select the wrong tool stack. You selected a database, and it's not fit for purpose. Maybe not fit for the data you're trying to ingest. Maybe it's not good at your semi-structured data, the JSON data, XML that you want to ingest. Could be maybe not the right SQL optimizer, not good at running window functions and so on, or analytical functions, essentially, and so on. So there's different issues that you can have with the tool stack, the ETL tool, and so on. Then what we've seen is very complex architectures, too many layers. Data is going back and forth between the layers. I've seen everything, essentially, where data is getting processed for a while and then pushed back all the way into an earlier layer, then instead of going all the way downstream, right? That's what we see sometimes. Not that much anymore, but still, well, we see complex architectures, to be honest. And then dependencies. The problem is that a lot of architectures, they use complex dependencies in the loading chain, and that leads to a lot of testing effort when you need to modify an artifact, because you have to test essentially all the dependencies. So reducing dependencies should be your goal, actually, when you build a data platform. And that's where I like Data Vault essentially for, because it's really based on the concept that you can have a system with zero change impact when you modify the existing model, essentially, or very close to change impact. We can achieve zero, but then the model gets a bit more complicated, but one way or the other works. And they often also use some modeling approach, which is just wrong. Maybe the question is Data Vault the right one for you, or is it not? You might find out after years of working on the Data Vault project, essentially, that might be the right one or not. I truly believe in Data Vault, but that has to be you, right? And but people find that out typically when they use something else and then realize, well, this approach is limited. And while Data Vault has a solution for their typical data-driven challenges, they have an issue with more traditional or other approaches, let's say. And then there's other risks and other issues in your team. There could be a lack of skills and knowledge. So you're using the most fancy technologies, but nobody's trained and doesn't know how to use these tools. So it's also an issue. We see it quite a lot. Distributed teams, they have their own challenges with communication and synchronization, right? And standards and so on. Then you have multicultural issues or communication issues where people don't understand each other culture-wise, essentially. Sometimes, at least in the Western culture, we nod our heads when we agree. Sometimes they what's called yeah, they do it the other right. So it depends really on the culture, and people might misinterpret this, especially if they're not used to different cultures sometimes. Budgeting issues, that you don't have the budgeting for your project, or you lose it because you don't deliver, for example. You're building a nice platform and nobody cares, so they cut your budget essentially, or you don't extend it. There could be political issues. We've seen this one as well, actually a few times, where just for pure political issues, political reasoning, a project gets killed or started or what else, right? So legal issues starting a project actually a lot, but also killing it sometimes. So that could be the case. So yeah. All right. And there's a human factor involved. The problem is data vault by itself, by design, can scale. So we can have essentially hundreds of teams working in parallel on the same data platform, working on different aspects of the data platform, different reports, different business values, essentially. And that's what we see. Personally, my biggest project where I was involved was essentially with 12 teams in parallel. I don't remember the individual team size anymore that much, but around this 5 to 9, I believe it was in a 7 to 8 range or something. And then you can count the numbers on around 100 people working on the data vault, essentially, on the data vault alone, right? I'm not talking about the data engineering teams around that, essentially. Just the data vault teams were 12 teams, roughly 7 to 8 people in a team. That's the basic idea. They can also scale down. So I also saw a project going from 25 people down to 2 people, for example. Also that one we saw when they had to scale down the resource, and yeah, just went down essentially with the resource and just maintained the system, so they could still run the reports they had, but they couldn't build additional reports essentially. So in the end, if you can scale that much, if you can scale from a small team, 5, 6 people, up to 100 people in 12 teams, really depends on can you hire the right talent, because that will be your limiting factor. Get the right people on board at the right number, right? So yeah, you always find somebody who claims to know data vault, or who is even certified in data vault, but has no freaking idea how that all works, or has a very unpragmatic view of stuff and of these concepts, and can't get a job done essentially, right? I mean, we can talk about real-time requirements, and we can build a real-time system in data vault at least. Even with Flow.BI, we can generate this model for that. The problem is, what if you don't need real-time, right? I've seen all kinds of stuff of consultants doing some weirdo stuff essentially in the project and wasting a lot of budget. And then so it's one thing is to get the right people, and then the right people with the right skill set essentially that you need. And that's typically the limiting factor. And when we compare this to Flow.BI, Flow.BI is an IT system. So it's a essentially it's a generative AI, as Patrick said, for generating or defining the raw data vault for all the hubs and satellites. It has the data vault training. I mean, it didn't went through it's not certified or something. Didn't went through a formal training, but it was trained essentially, right? So it was trained by us to understand data vault essentially and build those models. So we implement all the patterns that it needs to generate and define a data vault design essentially. It's also possible, or it actually learns from your data. So the idea is that there's a concept classifier in there which identifies the concepts inside your data set, customers, purchase, products, and so on. And while it keeps learning essentially based on your additional data sets you feed into Flow.BI, and you have to help it initially at least. But once it knows your data set, once it knows your concept classifications, it can apply this knowledge to similar data sets from you or from the customers essentially, and then it keeps learning more and more of these data sets. And when you attach a data set, there's a chance it knows a similar data set and can classify your entities as well essentially. That's the basic idea. The idea is that Flow.BI really generates and by calculation essentially, it comes up with an integrated enterprise data model for all your attached data sets. So it's not a data vault for one data source, it's a data vault across all your data sources, and it integrates the data sets. That's the basic idea. And the cool thing now is that Flow.BI is in the backend based on MVP clusters. I mean, we made sure we keep that from you as from a usage perspective. You don't see that, but in the backend there's MVP clusters that spin up, and when you attach thousands of source tables, these nodes spin up essentially and scale down again when you're done or when we're done. And so it can fully scale. No matter how many tables you want to attach, we can process those tables essentially. And and our standard setup is really so typically, when you build a data warehouse, you have a load date typically to be defined in a the load date is defined when the data arrives, and then you have a snapshot date that's in the morning. So at 7 or 8 o'clock in the morning, you build your PRT tables, and then you have your information, entities, the dimensions, and facts ready for consumption by the business users, so they can build reports essentially. So in the morning, you build a PRT table. What we do is we defined our snapshot date because we follow a similar concept. We define our snapshot date at 5 p.m. in the evening, typically. That's the default, at least you can modify that. But a 5 p.m. snapshot means essentially by 5 p.m. we start generating the logical model for your data sources. So over the day or in the last 24 hours, we essentially have processed your data from the data sources, and by 5 p.m. we start generating the logical model for the data vault. So we can hand it over to the database automation tools like Data Vault Builder or Data Vault for DBT, for example, for physical generation. So by the morning, you should have your new model essentially. When you use it roll in by 8 o'clock in the morning, it's all based on the latest version of the model. That's the design premise essentially. We start working when it gets dark essentially. That's where this title comes from for this today's session. How long does it take? It's really, to some extent still, it's defined by the largest table volume-wise, volume and shape-wise. So the biggest table in your data set, by the number of columns and the number of rows, that roughly defines the runtime. That's what we're working on by more and more distributing the workload. And we got a good amount of work already done. So it's not that hard anymore, not that challenging anymore, essentially. But that's still generally true. So the biggest table you have defines the overall runtime. Because there might be some situations where we have to calculate this table essentially for a while and then to get done. But again, because it's MVP based, while we're calculating this one table, we're also working on other tables, right? So that's the idea. And so Flow.BI really speeds up the time to deployment. That was the goal, to be able to come up with a data vault design overnight, absorb the data from the source systems, calculate the model essentially by using AI and expert systems and so on. And what we define essentially overnight is the metadata for the landing zone, like your maybe a staging area or landing zone on a data lake, for example, but also a relational database. It's up to you. The functional data lake, how we organize it by source system or source system defined metadata structures, and then the raw data vault. That's what we define here essentially. We don't define any business logic. So we don't define the business vault, the information marks. That must be all done by you essentially afterwards. And we also just define the data vault design with all the hubs and satellites, the business keys, the FAQ satellites, the satellite splits, and so on. But we don't generate the physical model, like the create table statements and the insert statements. That's all done by again, an established data automation tool like Data Vault Builder, Data Vault for DBT or something, where we hand over the metadata to these tools and they will generate the physical code for you. That's the basic idea. And then the data ingestion is done essentially. So if you automate this task, and you could automate this, generating the logical model with Flow.BI, handing over the metadata over to let's say Data Vault Builder, and then Data Vault Builder immediately generates the target model. You have the raw data done overnight essentially. That's certainly possible. Most clients don't do it in this case, but technically it's absolutely possible. Well, we'll do it like this, attaching thousands of tables. I would start small, to be honest. So we don't typically start with thousands of tables, source tables. The typical POC for Flow.BI starts much smaller with a handful of tables, let's say 25 tables something. Because when we do 25 tables and the client likes what I see, we can then scale it up to, let's say, 50 tables or 500 tables something. And we do this overnight or maybe week by week, in all honesty, but it's much faster, right? So we don't have to wait for years to calculate 5,000 tables. That's just what week 4 essentially. So we can scale it up and make sure that Flow.BI generates what the customer, the client expects from us. Essentially, that's the basic idea, to reduce the risk a bit. But it's also possible because we're just calculating it, right? So we're just using AI and expert systems to come up with the logical design, and that's it essentially.
Yeah.
All right.
So
Cool.
thanks for that. And this time we already received a questions in advance. So the first one was, can we regenerate data vault models every night and keep it up to date with the source system?
Yeah, that's a design premise. So we want to support a architecture where Flow.BI looks at the data sources day by day, identifies changes to the modifications to the source systems, and then comes to a point where it decides to make a new calculation. There might be different drivers why it should calculate a new data vault design, but typically it's the main factor is a structural change in the source system will trigger the regeneration of the data vault design. And the idea is to keep track of the source systems day by day, and when there's such a change, we then calculate the model. So the design premise here is that yes, we maintain your model essentially for the raw data vault and for the data lake and everything between the staging area and raw data vault. Yeah, correct.
And often ask how long will be the overall process to generate the data platform, including the physical model?
Right. So for Flow.BI side, it really depends again on your biggest table. There are some provisions or some tricks we use to reduce the runtime a bit. I wouldn't attach a terabyte or petabyte sized transaction table to Flow.BI. It's super expensive, not worth it. And it's a simple model. It's just a nonsense link and a nonsense link and a nonsense satellite essentially. So I would take that out. Flow.BI's advantage comes in when you have a lot of data shape. So we are more interested in those thousands of tables around this petabyte file essentially, right? Of petabyte table. That's number one. So the biggest table might define it to some extent. Again, it's get less and less important to be honest on this statement. But the biggest table defines it still to a bit. And then so it's not about the number of tables actually. So if you have 500 tables or 5,000 tables, it's really the biggest table defines it. That's it. And then the other thing is for the physical model, I don't know. Typically, it's not translating the metadata that comes from Flow.BI and applying the templates from the data automation tools to generate the physical code. That shouldn't be such. It shouldn't take too long essentially, not hours essentially. Yeah, that's the basic idea. So you can generally get this done if the process works, if the process is properly set up to generate the model day by day and hand it over to the data automation tool and generate everything. You can get this done by the morning essentially. It's not an overstatement essentially.
Yeah.
Cool. Any other questions or?
That's all for now.
Okay, cool.
So I guess we're done and would say see you next time.
Good. Thank you guys.
Bye.
Bye.